This is a project that doesn't end up in a way it should be. I uploaded the video because this project has taken quite some time, and since it's here anyway, I want to just upload it so I don't really waste all of my time. There are a few things you can actually learn from this project, which I'll explain in the video. Those things are how to use an AC current and voltage sensor, and how to use a micro SD card slot for Arduino, and a few more things. So I'm planning to make separate videos for those stuff. You might just want to watch this one. Enjoy and learn. The power meter I want to make will use a voltage sensor, which take the 250 volt AC into smaller microcontroller friendlier voltage. To understand how it works, I try to power it up and connect it to a standard mains supply and hooking the output up to an oscilloscope. And there we see that it reduces the voltage to supposedly about 100 times smaller than the real voltage. So I adjust the output to a perfect 1 per 100 of the input voltage. Next up, I get an ACS712 5A AC current sensor module, which if you read the datasheet you can understand how it gives an output voltage that's proportional to the current that passes through it. For the SD card, I got myself an SD card adapter for Arduino that has logic level converter built in, so the 3.3 volt micro SD card could cope with my 5 volt Arduino. For the beauty show, I used an OLED display I've used in the weather project thing video. And as you might already guess, the brain of this project is of course the simple, small and compact Arduino Pro Mini. But there's a problem when I started assembling the board. I want to make the device small and compact, and a bulky voltage sensor doesn't match with what I need. But once I thought of it, the voltage I'll be measuring will be pretty much the same, that is 215 volts AC. So I don't really need to use a voltage sensor, so I took that out of the list. Then I used a project box to pack all the things in later. I started by drilling a hole in the top of the box for my OLED display. I used some pack of a half a centimeter spacers to hold the display there, and it's already looking pretty good here. To see if all the things will fit in later, I try to put the board in first to kind of think what kind of design I'll have. I choose it to be like this. A cable that's plugged into main supply will go into the device will kinda interrupt the current with the current detector sensor, and then out to the other end to anything electronic appliances I might want to use. Then I started soldering things for the board. Start by soldering the components in place and try to imagine what it'll look like later, in case anything out of place might happen. Because the Arduino Pro Mini's I2C pins were not aligning with the protoboard so well, I used a wire from above and through the hole in the board and solder it bottom and top. Same goes for the other pin. Next, for the I2C that connects to the OLED display, I'll connect the pins to a male header that will later connect to the display with female wire. After the components were placed, I connected them all with some wires. It'll take some effort, but it's one of the most fun parts, so enjoy that. I first tried the SD card. I opened the card info sketch from the SD library example to test the SD card. There was a problem because I didn't change the pin select to 10, which is the pin I used, but once I did that, it works just fine. I opened the read-write sketch example from the same SD library and it worked perfectly fine too. Then I tested the display with the Adafruit display library and it worked flawlessly as it should be. So the only thing to do was to combine the codes into one. The current sensing thing was pretty much Arduino analog read, so I don't really need to explain things as simple as that. After coding for a while, I don't understand why, but there's something wrong if I try to use the SD card library. After a long time not finding where the mistake was, I figure out it'll be better for me to just not use the SD card thing rather than wasting my time finding an error in the library. So that's one fail for me. I figured out it'll be better for me to finish this project the way it is, so I drill a 1mm hole close to the display for my push button. Then for the power, I use a 2AA battery holder with a boost converter module, and then I set the output of the boost converter to 5 volt. After finishing all the input and output wirings and putting everything in the box, I screwed the top of the box to close it. Then it was testing time. I plugged the input to a mains 220 volt and then turned the device on. Then I tried connecting a drill to the output and turned the drill on, and the device kinda works. It looks like the device works. The bad news is that after testing it, the device only works on big currents larger than 1 amp. Below that, the device will read the same floating 0.26 amp, so that's another fail. I tried to use a pull down resistor for that and it doesn't work. The thing is, I've made a pretty good device, and even though it doesn't work the way I'd hope it to be, I had a pretty much fun time making this thing. That's it for this not so good project video. I hope anyone who watched this could understand where my mistake was, fix it, and then tell me where the mistake is, and see you next time.